Hello, can anyone respond? Okay, we will be starting now. So, this is optical fiber and wireless communication. So, we are starting with module one. Okay, students, like first module is very easy to score full marks. So, whatever the notes I've shared, the handwritten notes and the complete notes PDF, the complete notes PDF involves the textbook also. So, you have to study everything. Okay. So optical fiber, it's more of theory and problems, both it has and derivations we have. So we will be learning each and every step correctly. Okay. So am I audible? Okay. So I will be using this notes and even textbook also sometimes I will use. So what is an optical fiber? An optical fiber is a dielectric waveguide which operate at optical frequencies. So what is an optical fiber? If they give question, you have to write this definition, students. An optical fiber is a dielectric waveguide which operate at optical frequencies. The fiber waveguide is normally cylindrical in shape. See, whenever you have seen an optical fiber, it will be like this only, no? So it will be distributed like this. So what kind of a shape it is? It is cylindrical in shape. Okay. So the fiber waveguide is cylindrical in shape. Okay. See, very important, 6 marks question. Write about optical fiber structure. First question. So important question. See, uh, write about optical fiber structure. And they will be mentioning in the examination. For that, you have to draw this diagram. So core cladding. Optical fiber will be having three parts. Core cladding, actually two, but in cladding part, there will be one buffer coating extra for the extra protection. Okay. So this diagram you are supposed to write. N1 means it's a refractive index of the core. N2 means it's a refractive index of the cladding, where refractive index of the cladding is is always greater than the refractive index of the core, is always lesser than the refractive index of the core. So that you are supposed to write. This is optical fiber structure. So first you are supposed to draw this diagram: core, cladding, buffer, coating. The most widely accepted structure is the single solid dielectric of radius A. So radius of the core banbitu, it will be A. So entire radius will become 2A because core cladding will be there. No, so it will be 2A. This diagram you have to show of the and index of core, the refractive index is N1. This cylinder is known as core of fiber. So the core is surrounded by a dielectric cladding. See, these points you have to mention correctly. ಏನೇನೋ ಬರೆಯೋದಲ್ಲ. You have to write correctly whatever the system and textbook is demanding. Don't write your own words. So you have to write this dielectric cladding, which has a refractive index where N2 is lesser than 1. So first you are supposed to draw the diagram. Later, what you are supposed to write. So you have to write core refractive index N1, cladding refractive index N2. N2 will always be lesser than N1, and surrounding to it, it will be a buffer coding. First, you have to explain the diagram. That is your first step. Later, so what you have to do, you have to write. Although the principle of cladding is not necessary to propagate only the core of the fiber, so light cannot propagate only in the core of the fiber. It can also go towards the cladding and it can propagate through these several purposes. So what the cladding does, cladding work core ಬಂದ್ಬಿಟ್ಟು light na enter ಮಾಡಕ್ಕೆ and it, see, don't make disturbance, mute your mic. Along the core of the fiber, and it serves several purpose. So next, what is the work of cladding? The cladding work is it will reduce the scattering loss. So what is this? Like we will be learning what is scattering loss in the upcoming chapter. So this cladding will reduce the scattering loss that results from dielectric discontinuities of the core. See, light should come to the core. Whenever the light comes to the core, what happens? Because of the reflection nature, the light gets reflected in all the directions. Whenever you use that cladding, the scattering effects na it will be minimizing, so that discontinuity in a cladding will reduce. This is the work of cladding. Okay, and what it will do, it will add even the mechanical strength to the optical fiber. So see idarella baribeku. So see, are you able to understand theory and all? You have to learn like write and practice, students. Like right, like what is the function of core, what is the function of cladding, make one chart, like write, and then only you can remember. Don't just read and go, you might forget in the examination hall. So first draw the diagram, later on write down the point by point, maintain a separate notebook for optical fiber. Whatever the questions, whichever I give, whatever thought, learn then and there only, writing. If you waste time, definitely that time will not come back. So you have to work hard. Okay. Core. So I have told like cladding work ಏನು, core work ಏನು ಅಂತ. Core is made up of highly pure silicon dioxide and it is surrounded by the cladding. So core ali we will be using higher loss plastic core fibers with the plastic cladding are used. So higher loss plastic core, like core will be using a plastic one with plastic cladding. So plastic core and plastic cladding we will be using for the manufacturing of the optical fiber. Core is usually SiO2. It's a pure silicon dioxide. So in addition to that, most of the fibers are encapsulated in an elastic and abrasion resistant plastic material. This is called as a buffer coating, and this buffer coating, what it will do, students, it will minimize, it will provide the mechanical strength to the fiber, and it any if any geometrical irregularities, another geometrical irregularities if happens, or any roughness happens, that will be minimized by that buffer coating. Okay, so this much you have to write. So first you have to explain the diagram. Later on, you have to explain like what, why core, why cladding, and all are used, and how core is manufactured. Like what we will be using in core, what we will be using in cladding, and what plastic materials we will use. Next, you have to explain about the buffer coating, like how buffer coating is done and how we are using it, what kind of materials we are using it, and what's the work of the buffer coating. That, like that you have to go step by step. See, like if you write down the main key points, you can explain it directly. So don't get confused. Like for that, you have to write and practice everything. Okay. Write about optical fiber structure. If they give you, you're supposed to write this answer. 6 or 8 marks they are asking in the examination. An elastic abrasion resistant plastic material. Variations in the material composition of the core. In the first case, the refractive index of the core is uniform throughout and an abrogate. Okay. Still here you write about optical fiber structure. It's more than sufficient. The first important question I have already taught you. First important question is write about optical fiber structure. Next, very important. differences ಕೇಳ್ತಾರೆ. So difference between step index fiber and a gradient index optical fiber. So differences between step index and graded index fiber. So all the formulas you have to write down in one sheet of paper box. If you are not able to write, I will write and send after this module done. So you have to remember that formulas for the problems. Okay, problems I'll be teaching as soon as we do it. Okay, step index fiber and graded index fiber. In step index fiber ಬಂದ್ಬಿಟ್ಟು data rate ಬಂದ್ಬಿಟ್ಟು slow ಇರುತ್ತೆ. What's the meaning of data rate? So whatever you are transmitting in the optical fiber, that data rate will be slower in the step index fiber, whereas in the graded index fiber it will be higher. So what next? Coupling efficiency. Coupling efficiency ಬಂದ್ಬಿಟ್ಟು ulta, higher lower, which will be the higher and lower coupling efficiency. What is that coupling efficiency? The coupling efficiency is nothing but whenever you make to integrate with it, that 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 we will be calling as a coupling efficiency. Whenever you make two or optical fibers integrate together, so that makes the efficiency that will be higher for a step index fiber and lower for the graded index fiber. So path ray, which will be in the triangular form in the step index fiber, whereas in the graded index fiber, it will be in the zigzag orientation. So zigzag orient, like it will be in the sinusoidal way, with zigzag, and it will be sinusoidal. So index variation, see, like note down the formula, students. So they are in question, if they mention step index fiber, you have to use this formula. Delta is equal to N1 minus N2 divided by N1. So allow all of you open your mouths. Like what is N1? What is N1? What we will call N1 as? Talk, students. What is N1?
4.
It's a refractive index of the core. N2 is refractive
Cladding.
index of the cladding. So N2 should always be lesser than N1 for an optical fiber. So what is the function of cladding? See, like now only you learn. Don't waste time. Like whatever you are coming for 40 50 minutes, don't waste that time. Now like we'll let us learn later, like that and all. Not, don't need. Whatever you are doing now only you do. So learn, okay, for step index fiber, if in the question, if they are mentioned step index fiber, you have to use this formula, index variation. Delta is equal to N1 minus N2 divided by N1. If they are given graded index fiber, del is equal to N1 square minus N2 square divided by N1 square. Write this formula, all the differences, this and all you are supposed to remember. Formulas, everything. Step index, graded index, question problems they will be giving for 4 marks. So numerical aperture, NA andre numerical aperture. So numerical aperture remains constant in the case of a step index fiber, whereas in the graded index fiber, the numerical aperture will change. So what is the material used in the step index fiber? It will be glass or plastic. In the graded index fiber, only what we will be using, only glass we will be using. We will not use plastic in the graded index fiber. Graded index fiber efficiency is more. Okay, bandwidth is 10 to the power of 10 to 20 megahertz. So what is megahertz? Mega 10 power 6 or 10 power 7 megahertz.
10 power 6, sir.
Okay, giga,
10 power 9.
yeah. So So bandwidth yaduk jasti graded index fiber. So this points you have to use. You have to write. So ide use ಮಾಡ್ಕೊಂಡು ಬರಿಬೇಕು. Differences ಕೇಳಿದ್ರೆ 6 to 8 marks they will ask differences. So then you are supposed to write this and all. More Pulse spreading is more in the step index. Graded index ali LED. LL like light source for step index is LED. So LED full form. LED full form.
Light emitting device.
Light emitting diode. Okay. It's okay. Laser. Laser full form. Laser full form. At least Google ಮಾಡಿ ಆದ್ರೂ ಹೇಳಿ. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ ಇವಾಗ. Laser full form. Google it and tell me. What's Google showing? Laser full form. Light amplification by stimulated emission of radiation. Okay, very good. So, so applications. LAN bandutu local area network. I hope so. You will be knowing it. WAN bandutu wide area network, wide area and local area network. Okay, this 10 differences you have to remember. Will you remember, students? Step index and graded index. First optical fiber question na helkogotte. Next, 10 differences between step index and graded index fiber. Like after this class, you have to learn this. Don't postpone. So we will be going slowly only, like problems and all, but you have to learn. Okay. The next, so exam gathered important. Ade PDF I have included. 100% these questions will come. So next, there are two types of modes. Okay, single mode optical fiber and multi mode optical fiber. This is very important. So to calculate V number, you will be using this formula. So Elru, like write down this formula, V number, 4 marks problem. They will be asking you in the examination. Hello, 4 marks to 6 marks. They will be asking you problem from how to calculate the number. They will ask you directly. So I told you for step index fiber, what's the formula for this one? Delta. Can anyone tell me for step index fiber? See, be interactive. Learn now only. Only Shreyas R, Aryan is opening. Like what about Veena? Shreyas R, you don't tell. What about Veena, Priya, and Sophia? Please, like, don't get scared. You have to learn now only and go. We are teaching you important concepts, so you have to. This and all will come for the exam. So, what is step index fiber parameter index formula? I already told it's N1 minus N2 divided by N1. So N1 is refractive index of the core, N2 is refractive index of the cladding. Next, for if it's a multi-mode, no, if it's a graded index, it will be N1 square minus N2 square divided by, uh, it will become square, that's it. So ಈ ರೀತಿನೇ formulas ಕಲ್ತ್ಕೊಬೇಕು. Like you write whatever the formulas there in every module, you have to write and practice. Okay. Next, V number is on the formula. So what happened? What is numerical aperture in the case of uh, single this one step index fiber? Will it change or it will remain same? So our differences are so only it will be remain constant, whereas in the graded index it will like na hange revise ಮಾಡಿಸ್ತಾ ಇದೀನಿ. Okay, so V number formula 2 pi na into square root of 2 delta divided by lambda. Like learn this formula, V number. So we will do problems later. I will go like first theory mukse, like later I will do the problems. So first A banbutu radius of the optical fiber. Radius of the optical fiber is A. So that is 4. Del means it's N2 minus N1. Core minus cladding. Next cladding, N2 means cladding minus core you have to do. N means it's a mode, like which mode will be, like whenever I will do for problems, you will understand. Delta is wavelength, okay? So single mode optical fiber and multi-mode optical fiber, very important for 6 marks again. So tumba theory concepts idave optical fiber. So I need everyone to learn the theory concepts they are asking. Don't miss in any part whatever I'm teaching you. Single mode optical fiber andre we transmit in only one mode. See, only one mode we will be using. Draw this diagram. Core cladding. Only one mode is propagating through the optical fiber. So V number is lesser than 2.405. This you have to mention. Textbook points only we have written. So you have to mention this and all you have to remember. Core diameter is very less. See, core diameter ಬಂದ್ಬಿಟ್ಟು ತುಂಬಾ ಚಿಕ್ಕದಿರುತ್ತೆ. ಈ ತರ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ ತೋರಿಸ್ಬೇಕು. You have to show like in core diameter is very less in the single mode optical fiber, whereas in cladding what happens? In cladding it will be cladding will be more. So no dispersion effect. ಇವಾಗ ಲೈಟ್ ಒಂದೇ ಒಂದು ಇರೋದ್ರಿಂದ ಡಿಸ್ಪರ್ಷನ್ ಎಫೆಕ್ಟ್ ಆಗಲ್ಲ, ಬಿಕಾಸ್ ಯು ಆರ್ ನಾಟ್ ಯೂಸಿಂಗ್ more number of rays, right? Agutta dispersion, no, like you are not using many number of rays, there will no be dispersion effect. So you can understand easily. Don't buy art like theory, no, like maintained. Like if you see the diagram only, you can write the theory. Because of only one light ray, where you can expect dispersion, because only one light ray ಅಂದ್ರೆ ಇದು ಒಂದೇ ಹೋಗ್ತಾ ಹೋಗುತ್ತೆ. ಲೈಕ್ ನಿಮ್ಗೆ ತುಂಬಾ ಮಲ್ಟಿಪಲ್ ರೇಸ್ ಇದ್ರೆ ಡಿಸ್ಪರ್ಷನ್ ಎಫೆಕ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ನೋ ಡಿಸ್ಪರ್ಷನ್ ಎಫೆಕ್ಟ್. ಹೈಯರ್ ಬ್ಯಾಂಡ್ ವಿಡ್ತ್, ಸೊ ಇಟ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ 1000 ಮೆಗಾ ಹರ್ಟ್ಸ್. ನಾನು ಆಲ್ರೆಡಿ ಹೇಳಿದೆ ಇನ್ ಇನ್ ಸ್ಟೆಪ್ ಇಂಡೆಕ್ಸ್ ಫೈಬರ್ ಅಲ್ಲಿ ಹೌ ಬ್ಯಾಂಡ್ ವಿಡ್ತ್ ವಿಲ್ ಬಿ ಇನ್ ದ ರೇಂಜ್ ಆಫ್ ಮೆಗಾನಾ ಗಿಗಾನಾ ಇನ್ ಸ್ಟೆಪ್ ಇಂಡೆಕ್ಸ್ ಫೈಬರ್. In step index fiber, what will be the bandwidth? It will be in the megahertz or gigahertz range. Veena Priya, see students, like be attentive in the class. Like I'm stressing you because theory this is. You have to write, learn, practice, remember. Innu tumba tough will be there. Very good, Veena. At least text. If you are not able to talk, you can at least text. Okay. Fabrication is difficult. Fabrication is difficult because and it's costly for the single mode optical fiber because core diameter is less. Fabrication andre ಏನು like you will use some techniques and you will manufacture it. That fabrication is difficult. Because why it's difficult? Because core diameter ಚಿಕ್ಕದಿರೋದ್ರಿಂದ it will be complex to do, and it will be suffering from internodal dispersion. I will teach what is internodal dispersion, and there are two types of dispersion. One is internodal dispersion and intermodal dispersion. They've asked in your whenever you wrote your exam, at that time only they've asked what is internodal dispersion and intermodal dispersion. Okay, that I will teach you. Okay, you understood these points. Can you write difference ಕೇಳಿದ್ರೆ you write first diagram chart ತರ ಬರೀರಿ. If they ask just to explain about single mode and multi-mode optical fibers, write like this only. Okay, will this be easy? Are you able to understand? will you follow? Will you write and learn this today? Start from today only. Like how many ever your bags you have, I don't know. So I know, but you have to start. Give some time for one subject. Learn. See, I'm not taking entire syllabus and teaching you because you came in intention to clear to score 60 to 50 range. So for that, whichever questions I tell you have to do, you can get more than that also, but you can't skip whatever I teach. No, Aryan Barnwell, your voice is not at all audible. So I'm not able to hear. Okay. So in multi-mode optical fiber, what happens? There will be an acceptance cone. You can text me if you have any doubts. Okay. So in that we will be using many number of light rays. So otherly single mode only one light ray we used. So what happens? There was no any bandwidth, like it was of higher bandwidth, more number of. In this, what happens? The core diameter is more. Core diameter is more than the cladding. So V number is greater than 2.405. Then it will be having higher dispersion effect, and it's used for shorter distance communication. Fabrication is easy and not costly. So this you can write. So draw this diagram and explain. I've already shared the notes in the group. You can look down it. So this is another very important question, like step index fiber diagram. This they are mentioned in the textbook. Like you have to show this N2, N1. So single mode, mono mode step index fiber, how it will look. Like you have to remember this values. So in textbook, still well diagram is there. So you can refer it. Like if it's not clear, like to the rough work I have done it. Like I've already explained, single mode optical fiber, write about the index fiber. Like I already explained, like this values you have to remember. Multi-mode graded index, single mode. This diagrams only I've like briefed out. So I've shared the complete notes. In that you have this diagram. So this question is very important. So very important this question, students. Write about internodal dispersion. 6 marks, very important theory you have to write. So you have to write the diagram of the multi-mode graded index fiber. You have to write this diagram. ಈ diagram ಬರ್ದಿ 6 marks ಕೇಳಿದ್ರೆ, if they ask for 6 marks, you have to write this diagram completely, and you have to start with the explanation. What is internodal dispersion? So there is more number of concepts in optical fiber. So students, am I going fast or is this speed okay? Because this is your first class, because I can't go still slowly because I have to cover more concepts. Hello, what about others? Aryan, everyone, is the speed okay? Should I slow down? Are you able to understand? Hello, what about others? Hello, remaining students. Okay. So, yeah, okay. So, what is internodal dispersion and why it happens? Whenever an optical fiber is launched into an optical fiber, the optical power in the pulse is distributed. See, in optical fiber, there will be more number of rays. So propagating towards it. And each nodes, see, Vaga, in an optical fiber, whenever you consider the rays, if I consider this as one ray, and if I consider this as the second ray, and if I consider this as the third ray, will all these fibers move in the same direction and same velocity? Do you accept it? No. It will move in different velocity and in different speed and time. What happens at this time? This modes arrive at optical fiber end. So whenever this is the destination point of the optical fiber, they arrive at the different intervals of the time at causing a pulse to spread out, out. This process of delay is called as internodal dispersion. Okay, this you have to write. So whenever an optical fiber so is traveling in a multimode graded index fiber, draw this diagram, and this rays won't have um same velocity and same direction. So at that point, it reaches, this ray will reach at 5 seconds, you assume. This will reach at 10 seconds. This will reach 15 seconds. This, what happens? They will be causing the pulse spreading. So pulse spreading happens. This leads to the phenomenon called as internodal dispersion. If they have asked for 4 marks, you write this much. Draw the diagram and write about this. Okay, this is a model question paper question. Okay, consider a student's problem. Consider a multi-mode optical fiber. N1 is equal to 1.48 and N2 is equal to 1.46. Calculate the critical angle, numerical aperture, acceptance angle. So 8 marks problem. So multi-mode optical fiber. So for critical angle, formula is theta c is equal to sine inverse of n2 by n1. Remember, for every problem, you have to use this formula only. So, so theta c is sine inverse of n2 by n1. So sine inverse of n2 is to use your, like all are having your calculators. Hello? No, na. Why? You have sold calculators. Okay, use your calculator. I have shared the notes. You have to be ready. Like if you're in the class, means without calculators, how you are sitting in the class. Okay, so in calculator, you put sine inverse of 1.46 divided by 1.48. You will be getting 80.5 degrees. So for numerical aperture, it is square root of n1 square minus n2 square. So it's n1 square means 1.48 the whole square minus 1.46 the whole square. You will be getting 0.242. So calculation part you have to do. I'll teach the formula. So put, like if we go so slowly, we can't cover the entire 5 modules. Just 16 to 17 days left for your exam. So be good in calculation parts and all. Like you have to put just in the calculator. You know the formula, put it in the calculator. That's it. You will get 8 marks. So writing formula. So critical angle and all. It's critical angle means it's units is in degree. For numerical aperture, it is a constant value, it will not be anything. So 0.242. Acceptance angle, sine inverse of NA, whatever you have got sine inverse, that you have to put, whatever you got numerical aperture, you have to put, take the inverse of sine. So you will be getting the acceptance angle. Students, I had little work. Okay. So we have covered almost 25% of the 25% of the module. So I need everyone to learn and come till here, page number 7. So this is complete module. So we will go, we'll practice more number of problems, theory and all. See, the notes is very good. So you can expect. So I have written star and all. So this and all they are asking in the examination most frequently. See, there are 12 marks question. Attenuation and dispersion. It's 12 marks question, students. So uh, every paper you can expect attenuation, dispersion concept, and types of optical fibers they are giving for 8 marks. Ella theory. So what you have to do, you have to like write about single mode optical fibers, these problems. That's all. Module 1. ಇಷ್ಟು ಓದಿದ್ರೆ ಮಾಡ್ಯೂಲ್ 1 ಮುಗೀತು. Attenuation, dispersion, core cladding, mode theory of circular waveguides, formulas, everything. If you learn, module 1 is done. ಕಷ್ಟ ಇದೆಯಾ ಮಾಡ್ಯೂಲ್ 1? ಹಲೋ ಶ್ರೇಯಸ್, is module 1 you are feeling it's difficult?
No, sir.
First you have to learn the formulas, more theory is there, diagrams you have to learn. Then like ತುಂಬಾ formulas ಇದಾವೆ, ಅದೇನೆ like you have to write and practice entire formulas, everything. Like Wednesday and Thursday I will be taking 1.5 hour. Like we will go almost like by this week we will complete 1 and 2 module. ನಾನೇನು ಕಂಪ್ಲೀಟ್ ಮಾಡೋದು ಮಾಡ್ತೀನಿ, ನೀವು ಓದ್ಬೇಕು ಕುತ್ಕೊಂಡು. ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್ ಅದೆಲ್ಲ ಕಳಿಸ್ತೀನಿ. ಲೈಕ್ ಆರ್ಯನ್ ಡೋಂಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಕನ್ನಡ. ಸಿ, whenever I will be sending important questions, notes, stuff, everything, and I will be explaining whatever important is there. You have to maintain a separate notebook, write and practice all the theory key points. Just don't read. Your notes only will help you, your way of understanding. Okay, that's the way of studying. Don't just go through like, ayo, okay, okay. See, if tomorrow I'll be asking questions, then only I will proceed. I will see how much you have learned and come. If only serious students come to the class. Otherwise, please, I will refund your money. You can exit. So then only you can clear. Still, results have not come for basic signal processing and all. We will see like how much only serious students come to the class. Those who practice and come, because time is very less. Don't waste the time. This year only everyone should clear and go. So much difficulty